Rocket Lab, Past, Present and Future. Introduction. Rocket Lab, a revolutionary company in the aerospace sector, has made significant strides since its inception in 2006. Founded by Peter Beck in Auckland, New Zealand, the company's mission has been to provide affordable and frequent access to space, particularly for small satellite launches. This report explores Rocket Lab's journey from its early days to its current operations and future ambitions, delving into its technology's milestones and contributions to the space industry. Past, early years and foundational milestones. Rocket Lab was established in 2006 with a vision to develop a cost-effective launch vehicle. The company made history in 2009 by becoming the first private entity to reach space from the Southern Hemisphere with the launch of Electron. This marked a significant milestone showcasing the potential of private companies in space exploration. In 2014, Rocket Lab announced its flagship rocket, the Electron, which was designed to cater to the growing small satellite market. The Electron rocket stands out for its innovative use of 3D printing in manufacturing its Rutherford engines, which are entirely built using additive manufacturing techniques. This approach not only reduces costs but also accelerates production timelines, enabling Rocket Lab to offer competitive pricing for satellite launches. The Electron rocket had its inaugural flight in 2016, successfully placing multiple payloads into orbit. Over the years, Rocket Lab has launched more than 58 missions, deploying 203 satellites for a diverse array of customers, including commercial, civil, and defense sectors. Technological innovations. The Rutherford engine, a key component of the Electron rocket, is notable for being the first engine to utilize 3D printing for all primary components. This innovation has been a game-changer in aerospace manufacturing, allowing for rapid prototyping and cost savings. Additionally, Rocket Lab's development of the Electron rocket coincides with the United States Air Force Research Laboratory's AFRL long-standing history in propulsion systems dating back to the 1950s. The collaboration between Rocket Lab and AFRL has led to advancements in propulsion technologies benefiting both entities and reinforcing the importance of public-private partnerships in space exploration. Present. Operational success and global presence. Today, Rocket Lab operates advanced manufacturing and mission operations facilities across the globe, including locations in the United States and New Zealand. The company has successfully established itself as a reliable launch service provider with a significant number of missions completed and an impressive track record of deploying satellites. The Electron rocket can lift payloads of up to 150 kilograms to low Earth orbit, demonstrating its capacity to meet the needs of various clients. In addition to its commercial success, Rocket Lab has also been involved in important scientific missions such as NASA's Capstone mission, which aims to support future lunar exploration. Collaboration and partnerships. In the current landscape, Rocket Lab continues to foster collaborations with government agencies and private companies to enhance its capabilities. The AFRL's ongoing initiatives such as the Integrated Powerhead Demo (IPD) and Hydrocarbon Boost Demo (HCB) aim to transition advanced propulsion technologies to new space launch vehicles. These partnerships are critical for developing next-generation launch systems that meet the increasing demands of the space industry. Future. Development of the Neutron rocket. Looking ahead, Rocket Lab is focused on the development of the Neutron rocket, a larger vehicle designed to accommodate significant payloads and complex missions. The Neutron is expected to play a vital role in launching large constellations of satellites, particularly for applications like Earth observation and communications. This move aligns with the growing demand for reliable and efficient launch services in an increasingly crowded space environment. Innovations in propulsion technologies. The AFRL's future initiatives, including the Affordable Responsive Modular Rocket (ARMR) and Tactically Responsive Space Access (TRSA) programs, aim to enhance the United States space capabilities. The ARMR program seeks to reduce engine development time and costs substantially, while TRSA focuses on rapid access to space for military and tactical operations. Moreover, Rocket Lab is exploring innovative technologies like the rotating detonation rocket engine (RDRE), which promises to increase payload capabilities and efficiency. The integration of such advanced technologies will undoubtedly propel Rocket Lab further in the competitive space market. Timeline of key events: 2006, Rocket Lab founded. 2009, first private company to reach space from the Southern Hemisphere, Area 1. 2014, announcement of the Electron rocket. 2016, successful launch of Electron's inaugural mission. 2018 to 2023, continued success with multiple Electron missions and various payload launches including NASA's Capstone mission. 2021, announcement of Neutron, a larger reusable rocket. Ongoing, AFRL develops advanced propulsion technologies and engages in partnerships to enhance U.S. space capabilities. Conclusion: Rocket Lab stands as a testament to the rapid advancements in space technology and the increasing role of private companies in the aerospace industry. With its focus on innovation, cost-effectiveness, and collaboration, Rocket Lab is well positioned to continue its trajectory of success. As the company expands its launch capabilities and explores new technologies, it will play a crucial role in shaping the future of space exploration and utilization. The synergy between Rocket Lab and organizations like AFRL highlights the importance of partnerships in achieving ambitious goals in the ever-evolving landscape of space. Rocket Lab, past, present, and future. Rocket Lab, founded in 2006 by Peter Beck in Auckland, New Zealand, has made significant strides in the space industry, positioning itself as a key player in the small satellite launch sector. The company's journey from a startup to a leader in the aerospace industry is marked by several innovative achievements, particularly with its Electron rocket, which has become a popular choice for launching small payloads into orbit. Past. Rocket Lab's early years were focused on developing a low-cost launch vehicle aimed at making space more accessible. The milestone of becoming the first private company to reach space from the Southern Hemisphere was achieved with the launch of Area 1 in 2009. The company announced the Electron rocket in 2014, which was a significant turning point. Electron's design, powered by the Rutherford engine, incorporated 3D printing for all its primary components, showcasing a revolutionary approach to aerospace manufacturing. Notably, the Electron rocket allows for payloads of up to 150 kilograms to be lifted to low Earth orbit (LEO). Its inaugural flight occurred in 2017, and since then Rocket Lab has completed over 58 successful missions, deploying more than 203 satellites for various clients across commercial, civil, and defense sectors. The company's rapid ascent can be attributed to its focus on volume manufacturing and reliability. Present. As of now, Rocket Lab operates multiple facilities worldwide, including advanced manufacturing centers in the United States and New Zealand. The Electron rocket has solidified its reputation as the second most frequently launched rocket from the U.S., highlighting its reliability and efficiency. The company has developed a suite of technology and services that extend beyond launching satellites. It also offers spacecraft solutions, satellite components, and on-orbit management. A significant aspect of its current operations includes partnerships with various organizations, including the U.S. Air Force Research Laboratory (AFRL), which has a rich history in propulsion technology development. Rocket Lab has collaborated with AFRL to transition advanced technologies into new space launch vehicles, enhancing U.S. capabilities in space access. Future. Looking ahead, Rocket Lab is developing the Neutron rocket, designed for larger payloads and capable of supporting extensive satellite constellations for purposes such as Earth observation and communication. This move aligns with the growing demand for launching larger payloads and underscores Rocket Lab's adaptability in an evolving market. In parallel, AFRL is working on several projects aimed at enhancing space access capabilities, including the Affordable Responsive Modular Rocket (ARMR) program. This initiative seeks to reduce engine development time and costs significantly, while the Tactically Responsive Space Access (TRSA) project aims to enable rapid military access to space. Counterintuitive insights. 1. 3D printing in aerospace. While 3D printing has been touted as a game changer in various industries, its application in aerospace was initially met with skepticism due to safety and reliability concerns. Rocket Lab's use of 3D printing for the Rutherford engine's components challenges the conventional belief that traditional manufacturing methods are superior for critical aerospace components. 2. Small satellite market growth. Contrary to the belief that larger rockets are necessary for significant payloads, Rocket Lab's success with the Electron rocket demonstrates that there is a substantial market for smaller dedicated launches. This niche has been increasingly recognized, leading to the proliferation of small satellites and dedicated small launch vehicles. 3. Public-private partnerships. The collaboration between private companies like Rocket Lab and government entities such as AFRL demonstrates a shift in the traditional model of space exploration. Historically, government agencies dominated space access. But the success of these partnerships indicates that private companies can effectively contribute to national capabilities and innovation. For military applications, while many perceive space exploration as primarily a scientific endeavor, the increasing focus on tactical and responsive space access illustrates the military's growing recognition of space as a strategic domain. This shift in perspective may seem counterintuitive given the historical separation of military and civilian space efforts. 5. Market for affordable launch services. The notion that space access is prohibitively expensive is being challenged by Rocket Lab's business model, which emphasizes cost-effective, frequent launches. This has opened opportunities for smaller companies, researchers, and even educational institutions to participate in space exploration, fundamentally altering the landscape of who can access space. Conclusion. Rocket Lab has established itself as a transformative force in the space industry with a robust foundation built on innovation, cost-effectiveness, and strategic partnerships. The company's trajectory from a small startup to a major player in the aerospace sector exemplifies the potential for private companies to reshape space access and exploration. As Rocket Lab continues to develop new technologies and expand its operations, it stands poised to play a critical role in the future of space exploration and utilization. Rocket Lab, founded in 2006 by Peter Beck in Auckland, New Zealand, has made significant strides in the aerospace sector, particularly in the small satellite launch market. While much attention is often given to its achievements such as the successful launches of the Electron rocket and the development of the Neutron rocket, there are several important aspects within the broader context of Rocket Lab's history, operations, and future plans that tend to be overlooked. 1. The role of 3D printing in Rocket Lab's success. One of the most significant innovations attributed to Rocket Lab is the use of 3D printing in producing the Rutherford engine, which powers the Electron rocket. While this technological advancement has been noted, many may overlook its implications for the aerospace industry. The Rutherford engine is notable for being the first oxygen/hydrocarbon rocket engine to utilize additive manufacturing for all primary components. This not only reduces manufacturing costs and time but also opens up new possibilities for rapid prototyping and customization in rocket design. Significance: the use of 3D printing can democratize access to rocket technology, making it easier for smaller companies and nations to enter the space race. This could lead to a more diverse and competitive aerospace sector, fostering innovation and driving down costs for satellite launches. 2. Rocket Lab's approach to public-private partnerships. Rocket Lab's collaboration with the U.S. Air Force Research Laboratory AFRL highlights the company's strategic approach to integrating government and commercial interests. Through public-private partnerships, Rocket Lab has transitioned advanced propulsion technologies from the military to commercial applications, enhancing its capabilities while also supporting national security objectives. Significance: the ability to leverage government technology and expertise can significantly accelerate development timelines and reduce costs. This model could set a precedent for future collaborations between private aerospace companies and government agencies, fostering a more integrated approach to space exploration. 3. The importance of responsive space launch capabilities. Rocket Lab's development of the Neutron rocket aims to address the growing demand for launching large constellations of satellites, particularly for applications like Earth observation and communication. However, the emphasis on responsive space launch capabilities is often underappreciated. The Neutron rocket is designed to be reusable, which aligns with the industry's shift towards sustainability and cost-effectiveness. Significance: this focus on responsive launches is critical not only for commercial purposes but also for military applications. As global tensions rise and the need for timely intelligence increases, the ability to quickly deploy satellites can provide a strategic advantage. 4. The broader impact of the Electron rocket on small satellites. While Rocket Lab's Electron rocket is celebrated for its frequent launches, the broader impact on the small satellite industry is sometimes understated. The Electron has provided a dedicated launch service that many smaller companies and research institutions rely on to deploy their satellites. Significance: this democratization of space access can encourage innovation in satellite technology and applications. It allows a wider range of stakeholders, including academic institutions and startups, to contribute to space research and development, ultimately enriching the entire space ecosystem. 5. Rocket Lab's international expansion. Rocket Lab's strategic expansion beyond New Zealand to facilities in the U.S., including advanced manufacturing centers and launch sites, is a critical component of its growth strategy. This global footprint enhances its capability to serve a diverse customer base, but the significance of fostering international partnerships is often overlooked. Significance: by establishing operations in different countries, Rocket Lab not only broadens its market reach but also strengthens international cooperation in space exploration. This can lead to collaborative missions, shared technology advancements, and a more unified global approach to addressing challenges in space. 6. The focus on sustainability in space operations. Amid growing concerns about space debris and the environmental impact of launches, Rocket Lab's initiatives to enhance sustainability, such as reusability efforts with the Neutron rocket, are noteworthy. While the industry often focuses on launch frequency and payload capacity, the environmental implications of space operations are becoming more critical. Significance: emphasizing sustainability can position Rocket Lab as a leader in responsible space exploration, appealing to environmentally conscious investors and customers. This approach also sets a standard for other companies in the industry to follow, encouraging a shift towards more sustainable practices in space. 7. The evolution of Rocket Lab's business model. Rocket Lab's transition from solely a launch service provider to a comprehensive space solutions company offering spacecraft satellite components and on-orbit management reflects an evolution in its business model that may be overlooked. This shift allows Rocket Lab to capture more value in the space economy and respond to the growing demand for integrated solutions. Significance: by diversifying its offerings, Rocket Lab can mitigate risks associated with fluctuations in launch demand and position itself as a one-stop shop for clients. This comprehensive approach can foster long-term customer relationships and drive revenue growth in a competitive market. Conclusion: Rocket Lab's journey from a small startup to a major player in the aerospace industry is marked by significant technological innovations, strategic partnerships, and a commitment to sustainability. While many of its achievements are celebrated, the underlying themes of democratization of access to space, the importance of responsive launch capabilities, and the evolution of its business model are critical to understanding its impact on the industry. Recognizing these often overlooked aspects can provide a deeper appreciation of Rocket Lab's role in shaping the future of space exploration. 1. Innovative launch systems and technology. Rocket Lab's flagship rocket, the Electron, represents a significant advancement in the small satellite launch sector. It employs the 3D printed Rutherford engine, showcasing innovative manufacturing techniques that reduce costs and improve reliability. The use of volume manufactured systems has enabled Rocket Lab to become the second most frequently launched U.S. rocket, thus supporting the increasing demand for small satellite launches. This focus on innovation not only highlights the company's engineering capabilities but also sets a precedent for the future of aerospace manufacturing. 2. Public-private partnerships and collaboration. The collaboration between Rocket Lab and the Air Force Research Laboratory AFRL serves as a prime example of how public-private partnerships can accelerate technological advancements in space access. Through initiatives like the Integrated Powerhead Demo IPD and Hydrocarbon Boost Demo HCB, AFRL has shared expertise and resources that enhance Rocket Lab's propulsion technologies. This synergy exemplifies how partnerships can foster innovation and enhance national capabilities in space exploration and defense. 3. Expansion into larger launch vehicles. Rocket Lab's future development of the Neutron rocket signifies a strategic shift towards accommodating larger payloads and missions. As the demand for launching large constellations of satellites grows, Rocket Lab's investment in a reusable, larger launch vehicle positions the company to capture a significant share of the market. This evolution reflects the broader trends in the space industry, where the capabilities of launch providers must grow to meet the changing needs of satellite deployment and space infrastructure. 4. Holistic approach to space access. Rocket Lab is not just a launch service provider, it aims to deliver complete spacecraft solutions. By developing satellite systems and components, Rocket Lab is creating an ecosystem that simplifies the process of accessing and utilizing space. This comprehensive approach facilitates a variety of missions across commercial, civil, and defense sectors, effectively democratizing space access. The company's vision of making space more accessible underlines its commitment to the future of space exploration and utilization for various stakeholders. 1. SpaceX's Falcon 1 and Falcon 9 development. Past, SpaceX was founded by Elon Musk in 2002 with the goal of reducing space transportation costs to enable the colonization of Mars. The Falcon 1, their first orbital rocket, made its maiden flight in 2006 and became the first privately developed liquid-fueled rocket to reach orbit in 2008. The Falcon 9 followed with its first flight in 2010, designed for reliability and reusability, making it a game-changer for commercial space travel. Present, SpaceX has since revolutionized the aerospace industry, achieving numerous milestones, including the first reflight of an orbital-class rocket in 2017 and the first successful crewed mission to the International Space Station ISS in 2020. The Falcon 9 has become the workhorse of the satellite launch industry. Future, SpaceX is currently developing the Starship, a fully reusable spacecraft intended for missions to Mars and beyond. The company aims to establish a human presence on Mars, further pushing the boundaries of space exploration. 2. Blue Origin's New Shepard and New Glenn. Past, founded by Jeff Bezos in 2000, Blue Origin's early focus was on suborbital flight with its New Shepard rocket. New Shepard completed its first successful crewed flight in July 2021, marking a significant milestone for commercial space tourism. Present, Blue Origin is actively developing the New Glenn, an orbital-class rocket designed for reliability and low cost. They have secured contracts for various satellite launches and are focusing on expanding their capabilities in both suborbital and orbital markets. Future, Blue Origin's vision includes establishing human presence in space through projects like the Orbital Reef Space Station and Lunar Lander systems as part of NASA's Artemis program, aiming to facilitate sustainable human exploration of the Moon and beyond. 3. Northrop Grumman's Antares and Cygnus program. Past, Northrop Grumman's Antares rocket, first launched in 2013, was designed to deliver cargo to the ISS as part of NASA's Commercial Resupply Services program. This marked a significant step in public-private partnerships for space exploration. Present, Antares has successfully completed multiple missions, delivering supplies to the ISS using the Cygnus spacecraft. Northrop Grumman is continuously upgrading the Antares rocket and Cygnus spacecraft to enhance capabilities and reliability. Future: the company plans to further develop the Antares rocket and Cygnus spacecraft while also contributing to new missions including lunar landers and deep space exploration projects, thereby ensuring continued support for NASA's Artemis program and human exploration of the Moon. Future outlook for Rocket Lab. As Rocket Lab continues to innovate and adapt in the rapidly evolving space industry, several key predictions can be made regarding its future trajectory. This outlook will focus on advancements in technology, market expansion, partnerships, and the overall impact on the space economy. 1. Advancement in launch capabilities. Neutron rocket development. Rocket Lab's upcoming Neutron rocket is expected to significantly enhance its launch capabilities. Designed for larger payloads and reusable, Neutron is strategically positioned to cater to the growing demand for launching satellite constellations and interplanetary missions. By 2026, it's anticipated that Neutron will be operational, allowing Rocket Lab to compete more aggressively against larger launch providers such as SpaceX and Blue Origin. Increased launch frequency. With the Electron rocket already being the second most frequently launched U.S. rocket, Rocket Lab is likely to increase its launch cadence further. The efficient manufacturing processes and the modular design of its rockets may lead to a doubling or even tripling of launches annually by the end of the decade. 2. Expansion of service offerings. End-to-end space solutions. Rocket Lab is poised to expand its service offerings beyond launch services. As an end-to-end space company, it plans to provide comprehensive solutions including satellite design, manufacturing, and on-orbit management. By 2030, a significant portion of the company's revenue may derive from these diversified services rather than solely from launches. Innovative spacecraft technologies. The company's advancements in spacecraft technologies such as the Photon satellite platform indicate a shift towards integrated solutions that encompass both launch and satellite operations. This could lead to partnerships with governments and organizations that require complete mission solutions, further solidifying Rocket Lab's market position. 3. Strategic partnerships and collaborations. Public-private partnerships. Continued collaboration with entities like the Air Force Research Laboratory (AFRL) will enhance Rocket Lab's technological edge. As AFRL looks to develop responsive and modular rocket systems, Rocket Lab's involvement could lead to new propulsion technologies and innovative launch systems, making U.S. space access more competitive. International collaborations. As global interest in space exploration grows, Rocket Lab will likely pursue international partnerships to facilitate launches for foreign governments and organizations. This could see Rocket Lab expanding its footprint in markets like Europe and Asia, where demand for reliable launch services is growing. 4. Market adaptation and response to global trends. Growing demand for small satellites. The small satellite market is predicted to grow significantly in the next decade, driven by demand for Earth observation, communications, and scientific exploration. Rocket Lab's focus on small satellite launches with Electron positions it well to capitalize on this trend. By 2028, it is expected that the company will be launching a significant percentage of small satellites deployed globally. Sustainable practices. As the space industry faces increasing scrutiny over sustainability, Rocket Lab may lead initiatives to reduce the environmental impact of launches. This includes developing more eco-friendly propulsion systems and exploring options for debris mitigation, such as end-of-life satellite disposal solutions. 5. Technological innovations. Advancements in propulsion technologies. The exploration of cutting-edge propulsion technologies such as the rotating detonation rocket engine (RDRE) could revolutionize launch systems. If successful, these innovations could enhance performance and reduce costs, potentially making Rocket Lab a leader in next-generation propulsion systems by the 2030s. Automation and AI in launch operations. The integration of automation and artificial intelligence in launch operations may streamline processes and improve turnaround times. As Rocket Lab adopts these technologies, it could achieve unprecedented efficiency levels, making space access quicker and more affordable. 6. Impact on the space economy. Catalyst for new space startups. Rocket Lab's success could inspire a wave of new space startups, fostering innovation and competition within the industry. By providing reliable launch services and comprehensive support, Rocket Lab may act as an incubator for emerging companies, further enriching the space economy. Integration with commercial space activities. The line between government and commercial space activities is blurring. Rocket Lab is likely to engage more with government contracts, especially in defense and research, solidifying its role as a critical player in national security and scientific endeavors. Conclusion. Rocket Lab's future is poised for significant growth and transformation. By leveraging technological advancements, expanding service offerings, and fostering strategic partnerships, the company is well positioned to navigate the complex landscape of the space industry. As it continues to innovate and adapt to market demands, Rocket Lab is not just a participant but a potential leader in shaping the future of space exploration and utilization. The next decade will be crucial for Rocket Lab as it strives to maintain its competitive edge and fulfill its mission of making space accessible to all.